As you can see, this presentation is by Fustino Brothers FBI Apps. We're originally from Western New York. That's why we have a little picture of Niagara Falls at the top there. And our slogan is building powerful apps for rock stars. Powerful being the powerful Niagara Falls. And the rock stars will show you a slide about that coming up. And I think it's time to do the introductions. What do you say, Russ?
Sure thing, Gary. Go ahead.
Okay. Gary, I'm
with
middle there.
Go ahead, Gary.
Do web design, business social media, and marketing for the group. Belong to the Bluffs Business Association here in Florida, which would be in Tampa Bay, and associated also with the St. Pete Chamber and a few of the technical groups, MAD being one of them. Okay, Russ, take it away.
Well, actually, I'm going to turn it over to Rich. Rich, are you on? You can do your first,
am.
and then I'll do mine last and go right into the introduction for Tim.
Hi, I'm Rich Fustino, a musician. I'm a teacher at Matt's Music. Been there for 54 years. I've given over 70,000 guitar lessons. I, in my spare time, do the Jethro Tull newsletter, which I'm working on today. It'll be published this afternoon. I've been doing the Week of Rock at Matt's Music, and for 13 years, I put together 30-some kids every August, and 1 week's time, we put a rock show on Fridays, and I do the same thing at Crossroads Music. And I work on all the videos in this Jethro Tull app and fan videos, and just kind of go through all the stuff that makes Jethro Tull such an exciting performer. Take it away, Russ.
Well, thanks, Rich, for that great introduction. And Gary put up the slide of our app that's in the app stores. My name is Russ Fustino. I'm head up the Mobile Application Developer Group. This is a joint meeting with Mobile App Dev and FBI Apps. And so we hope you enjoy this session we got coming up. And I'm a former Microsoft MVP as well as the coder. I'm the coder of the three for building that Jethro Tull app that you saw on the screen from Gary. And so, yeah, let's go over to this slide with about our guest speaker and get this going, because I am very excited to bring this to you. I saw Tim a few months ago down in Bradenton over at the Station 2, wasn't it, Tim? I think it was. We did a session over there and started talking, hey, Tim, why don't you come do a session for our group? And I'm going to end up doing a session for his group down in Bradenton, too, later on. But anyway, for those that don't know Tim, he's a principal systems engineer, avid technology enthusiast, software engineer, speaker, experienced IT executive who's worked with a variety of industries, including accounting, travel, insurance, e-commerce, and transportation, where he has spearheaded the adoption of agile engineering and the design development of modern technology, infrastructure, and application architectures. So Tim's Twitter is at Tim Chaffee, CHFFEE, and same for the GitHub address. And I think most importantly, Tim, you are a former RussCam interviewee, correct? When I did the RussCams?
Well, I know, we did a presentation in the Naples, I think it was, Naples.net meetup, and had that there, and we interviewed there. So it was really good. Yeah, it's great.
Well, listen, why don't you go ahead and take the screen and get going? I don't think we have any PowerPoints. We're going to do all demos here. And questions like, why do I care about running an ASP.NET, app on a Raspberry Pi, as well as, what's this IoT thing all about? Tim will answer for you, and some of the great benefits and some of the business solutions that could be done with that. So with that, I'm going to shut up and leave it up to you there, Tim. Go ahead and knock them dead.
All right. Thanks, Russ. Thanks, Rich. Thanks, Gary. I really appreciate you inviting me on your show. I'm excited to present today on IoT. When we talk about IoT, it's a very broad term, right? And I think of IoT as connecting anything in the physical world to the internet. So we're going to do that today. And one of the reasons you might ask is, why would we do that on a Raspberry Pi? Well, the Raspberry Pi allows you to interface with the real world. And it does run a Linux variant or Windows IoT Core. So today we're going to go over how to run .NET Core on a Raspberry Pi running Linux, which is the Raspbian distribution based on the Debian distribution on this device here. And what we're going to do is we're going to simulate interacting with the real world by turning this LED here on. So when we do stuff, I'm going to want you to look at this LED where you see this nice LED here with my Vanna hands.
Mhm.
And we're going to go ahead and turn that light on and off. And why would you want to do that, though? Why would you want to connect to something in the real world? Well, almost everything you have today is connected to the real world. One of the quick ones that I think everybody has is a router, right? A Wi-Fi access point that you put in, and it has a web interface that you connect to actually interact with the device and configure the device. But we have a lot of newer ones like the Nest thermostat. You connect to that, you can connect to the web interface and control your Nest thermostat over the internet. We have the Ring doorbell where you can have a camera on your doorbell. So one of the things that you can do is I've got a Raspberry Pi here connected to a camera, connected to a couple of servos that can pan and tilt that camera so I can control that pan and tilt from the web. So that's maybe a real world application of something you'd want to do is pan and tilt from the web. So why .NET Core? Well, a lot of engineers like C# as a language. I personally like C# as a language, and I want to write in .NET Core. It's the business application software that I'm used to writing in. So I want to write in .NET Core, and the release of ASP.NET Core allows us to work on Mac, work on Linux, work on different CPU architectures like the ARM architecture that this runs. So this little device runs an ARM v7 CPU. It's a Raspberry Pi Model 3 B+, and this device costs about $35, and it's about as powerful as your Pentium computer from, I'm dating myself a little bit, from, a while ago. And it can run, pretty much anything. It runs a full operating system, the Linux operating system. This is a little different than something like this, which is some particle microcontrollers. And those microcontrollers can also interface with hardware, but they run C++. And you have to program in C++ on it, and you can still interact with hardware. Now, the difference between a microcontroller and the Raspberry Pi. The Raspberry Pi is a full computer. I've got an HDMI port here, USB ports. Let me hold this one up so you can see a little better. I've got an HDMI port, Ethernet jack, USB ports, just like a regular computer. So with this computer, you can do anything a standard computer can do. The downside of this is it's not low power. It's high power compared to these devices. Now, I just want to give a little segue here, quick jump into share my screen. Let me share my screen. Share my entire desktop. All right. So Wilderness Labs has this microcontroller they're getting ready to release called the Meadow. They had a Kickstarter for it. I think they're going to release it around the June timeframe and actually ship it to their the people that ordered it. And it is a low power microcontroller that will run .NET Standard and .NET Core. So if you wanted to do something really low power in .NET, I'd say check this out when it comes out. But it's always great to get started on the Raspberry Pi because you can get it today, costs $35, about $50 once you get the SD card and the power supply and everything else you need. All right, so what we're going to do is we're going to showcase running on .NET Core on the Raspberry Pi, and we are going to turn this LED on and off. We're also going to show that you can use standard built-in .NET Core libraries, standard .NET Standard libraries. You can connect to SQL Server, and you can interact with the real world, all while doing that on the Raspberry Pi. So, Russ, any questions?
Not so far. I mean, what about Windows 10? Can you run that on there?
Yeah, so this runs Windows IoT Core as well. One of the reasons why I picked Raspberry Pi and the Linux operating system on the Raspberry Pi versus Windows IoT Core is Windows IoT Core is rather new. It's still being developed. I did experience a few problems with this latest B3 Model 3 B Plus and the Wi-Fi on it, and it wasn't ready for that yet. And the Debian operating system that this is based on is tried and true and been around for a while. Also, I really like the idea of running my .NET Core apps on the Linux operating system, on a different operating system than Windows.
Okay, hello, this is Gary. I just want to interject. We have a couple guests that have joined us. If the new guest, Michael, John, and so forth, if you could mute your mic, that would be appreciated, and then join in at the end with question and answers. Thank you. Thank you very much.
Great. Yeah, I'm going really fast. There'll be some links in here. Everything I'm going over today, there are instructions for on the internet, and you'll be able to see those in the links with the video that they post of the recording of this session. So, I'm going to go really fast because I have a lot of things I want to cover, and I really hope to get to my surprise at the end for everyone. All right, so I'm connected over here to my Raspberry Pi. I'm actually going to quit this and go back and clear the screen. So this is my Raspberry Pi. You can jump on it and you can see some files on here. I'm in my home directory, and I'm connecting to it through SSH, which is a secure shell, and that's a protocol that we use to connect to Linux machines. And you can connect to other types of machines with that too. But primarily, it's we're used to that from the Linux world. And in there, I'm also connected to the machine in this program called WinSCP, which allows me to copy files back and forth between my machine and the Raspberry Pi. And that using the SCP protocol or secure copy protocol. And that is something that you can also do with the command line, but I like to use the GUI because, for beginners, it's much easier, I think, to jump in here and be able to, understand what they want to do. So let's go over the first app real quick. The first app is called Blinky, and all it's going to do is blink this LED. You can see I'm running in Visual Studio. I'm running C# code. I've included a few NuGet libraries from a company that are provided from this UnoSquare Raspberry Pi IO. I started on this adventure before Microsoft announced the system devices GPIO, which I'll show you in a minute, and we'll do a similar program using that library. That library is in pre-release. And I'm not sure yet if it has the camera, but when I first started interacting with the Raspberry Pi and .NET Core, this was the library that I found that allowed me to interact with the real world and the camera and everything else. So we're just going to go ahead and run this to get the running set up. To get this set up to run, you have to install the .NET Standard and a few other libraries, but all that's very well documented. It's over here in the .NET Core repo in GitHub. They've actually got all the instructions for working with the Raspberry Pi, right here. So it allows, everything's here that you need to do to get it set up and get it running. So I'm not going to go over that in the interest of time. And let's go over to the device, and we're going to go into the Blinky folder, and we're going to run it. So everyone, keep your eye over here on the LED. We see it turning on and off. And one of the other things is,
baby.
One of the other things this library does is it allows you to get a lot of system information, like the CPU architecture and hardware. You can see where I'm doing that right line there. And we come over here, we can see that information on the screen here. I'm going to highlight like it's running Linux. It's the ARM processor. So right now we've got .NET Core running on an ARM processor, running the Linux operating system. And we're blinking a light in the real world.
That's cool. Right. Tim, did you show the diagram of the?
No, that's great. That's great.
The pins and how it's all connected.
Yeah. So here's a diagram of the Raspberry Pi and the I/O ports. This shows you all the GPIO ports that I was talking about, the general purpose I/O ports. That shows you how you can connect to the real world. And a general purpose I/O port is basically that. It's a general purpose I/O port. It allows you to turn things on and off. It allows you can vary the voltage using something called pulse width modulation, or PWM, and that is a way to simulate a lower voltage by turning on and off the voltage really fast. It also supports some higher level protocols like I2C or SPI. I think sometimes this is pronounced I2C, but I just learned it from reading. So I2C or SPI, those are two higher protocols that allow you to connect. So right here, I've got a temperature sensor. This detects humidity and temperature. It uses the I2C protocol to connect, and you can connect that. And you could, actually, one of the demos I had here on this device was connecting using a temperature sensor. When the temperature hit a certain temperature, turning the light on. So you'd know it was warm enough or cold enough. So that could also be something you use maybe in an industrial situation where you're have lots of air handlers and you're detecting the temperature coming out of the air handlers has risen. It's too hot now. It's not cooling good enough, and do some preventative maintenance on preventative maintenance on that AC unit before it actually goes bad. Maybe you could go check the Freon or something like that. And then let's get a quick close-up of how this is actually connected. So this is connected to the Raspberry Pi. It's connected to the ground using a breadboard. This is a breadboard. It allows you to easily connect electronics, little circuitry together. And then we've got the pin 17, GPIO pin 17 connected to this resistor connected to the LED. So that's what we see here. The red is the positive, or the, where the voltage is going to come from. And here's the ground connected to the LED.
Awesome.
Yeah, so now where I got this diagram from, right? I got this diagram from the devices, the IoT.NET IoT GitHub project, right? And the .NET GitHub IoT project is where Microsoft is starting to do GPIO as a first-class citizen. So this is an open source project where they're releasing IoT libraries to talk to not just the Raspberry Pi, but lots of different devices. The Raspberry Pi is one of the first ones that they're starting with, but it'll allow you to talk to GPIO and other devices. So this is one of the links that you'll have available later where you can go through. But I went into one of the samples here, the Blinky sample. And that's where I got the little diagram from and everything. And that's,
Nice.
This is where you can go get this same exact sample that I'm going to show you in a minute. Also, I wanted to highlight that they're going to interact with a lot of different devices. So this temperature sensor, this is an SHT31 right here in that same GitHub repo. You can see SHT31X. I mentioned it was I2C. Well, here you see its I2C address, and you can see that same sensor I have with a nice, great picture of it, and how you interact with it using this IoT library. So the great part about this is it's supposed to be released with .NET 3, which is in preview right now. This is a preview release, so if you want to use it, you have to set your NuGet to enable preview release. So let me show you that. So this is a similar program. Let me go over here and make sure I've stopped it from blinking. This is a similar program. But it's using the system devices library. So we'll zoom in real quick so you can see that. The system devices GPIO. That's from Microsoft. That's from that GitHub repo. It's pre-release, so when we look at our NuGet packages, we have to make sure we have include pre-release checked here, and you can see that it's a preview release here, pre-release. All right, so you might be asking, all right, so I'm writing this on Linux, and yeah, that's great. You're interacting with the real world, but what's the debugging situation like? How do I debug this? How do I interact with these things? How do I actually, can I, I'm so used to interactive debugging and stepping through my code. Well, absolutely. I've got a little line in here that basically says, well, the debugger is not attached, just loop. And we're going to go over to the device. We're going to go into the folder that's running that, and we're going to run it, and we're going to say it's waiting for the debugger to attach. So what I can do now is in Blink GPIO, I can go under debug menu, and I can attach to a running process. So this allows me to attach to something that's already running, whether it's on my machine or a server or this Linux machine. Now, I mentioned earlier that we're connected here over SSH. That's the same way you're going to connect to the debug experience. Is you're going to come in here and you're going to select in the connection type in the dropdown, Secure Shell is your connection, and then your connection target is your username at the IP address. Now, the next thing you're going to want to do is come down and click on Show Processes from All Users. That's going to show all the processes. And then the easiest way to find your process, I find, is just to type in here the start of the process, and you can see here we've got Blink GPIO. I can click on that. I can attach to that process. I can tell it I'm debugging a managed.NET Core for Unix. Come over here. Look at that, debugger attached. Look at that, I just hit that breakpoint. So we were waiting for the debugger to attach, right? And I have it set with a conditional compile to only do that in the debug mode. And now I'm at this breakpoint, so I can step through this code. I can highlight, I can hover over a variable and see the actual value of the variable. All right, so let's do this again. Wait, I kind of went through that fast. you didn't see the light turn on. I didn't point to the light to turn on. Well, you know what I'm gonna do is I'm just gonna right click up here and say set next statement, just like I can in the real world, you know, when I'm debugging on my machine locally. And then I can hit F10. Right now you can see a little bug there. It didn't move the yellow up to that line, but it actually did move us to that line, because when you see when I hit F10, we move through there. So I want everyone to watch right here now, and I'm gonna hit F10 and the light goes on.
Yay.
Right? I'm interactively debugging this IoT internet connected device. Right?
I can see that.
Yeah, so I think that's pretty cool. I can debug the device right from my local machine, you know, remotely.
That's so cool.
Now, one of the things you have to do when you're want to run something on Linux and ARM that I'm just going to point out that's not obvious. If you're using Visual Studio 2017, there's some tricks you have to go through. The great thing is in Visual Studio 2019, which I really recommend you use if you're going to do this, is you can, when you want to publish this, you can come into Publish and set up a Publish profile. And if you edit it, you can actually pick as a target runtime Linux ARM.
Oh.
Yes, you couldn't do that before in Visual Studio 2017. So what you had to do is you had to say publish, and then you had to go manually edit the config file to say Linux ARM. Now it's in here in Visual Studio 2019. But you do also need to pick self-contained so that it contains everything you need to run it in that one directory. And then you pick Linux ARM and you can publish it, and then you copy those files over. And then once they're copied over, I want to highlight one other thing. If you're not familiar with Linux, there's something called like file permissions, that files can't be aren't executable by default. So when you want to run something like Blinky, you have to change or modify the file permissions. And on Linux, that's a chmod command, or makes it much easier if you're using something like WinSCP. You can just come into properties on the file. So Blinky here is our equivalent on Linux, is our equivalent to our Windows executable. And you just need to make sure that it has this X for executable checked. Now I've just checked everything in permissions, and that's 777 is the actual in octal. So you can also do that to command line in Linux if you're real familiar with that. All right, so we talked about ASP.NET, right, Russ?
Yes.
We talked about a website.
.NET? Yes.
Yeah, so ASP.NET, standard.NET standard library, ASP.NET Core. We're going to go ahead. I've got a standard. I just created a .NET Core, ASP.NET Core website, standard website. I actually took one of the other MVPs developed with like their best, recommended ways of doing things and coding things. And it's got a mini profiler from the folks at Stack Overflow already included in it and stuff like that. So we can see how the timing on these things and how long everything takes. So this is a, standard. We can run it on my machine. I'm going to go ahead and just click run here.
And again, one use I think you mentioned to me earlier of doing a web-based interface is it'll look nice, right? You can actually like get at settings and all that stuff a lot easier and a lot more user-friendly. Is that right?
Yeah. So I mean, if you think about it, you wouldn't want to go to the command line to configure your Nest thermostat or your Ring doorbell, right? You just want to set it up by going to a nice website like this one, right? So this is just a .NET Core website running on my machine. It connects to SQL Server. Right, I can log in here. It's connecting to my SQL Server running up on Azure, and actually log into SQL Server. You can see up here I got mini profiler running that tells me how long things are taking to run. On my machine, it's actually not that quick. Look, it's taken 200 milliseconds to return some of these pages. Right, the home page 86 milliseconds. Let's see if it gets any faster. You notice there's a little toggle button on here. Right now, if we click that, it's going to blow up. Well, it's going to hit my breakpoint first, and then it's going to blow up where they're not supported because the GPIO isn't supported on this platform. On my Windows machine, I don't have any GPIO that we can control. So I'm going to go ahead and just stop that. We're going to go over to the device, and we're going to go into my web folder. And actually, let's see if nope. I want to type in this command here, which is basically saying run the .NET Conf application, bind to this URL, so listen on port 80 on this URL, and I'm setting the environment to development, and I'm doing that just so we can see some of the messages that come back on the UI. In production, you could set that to production. So this is going to actually run the website, and we're going to connect to that website on the Raspberry Pi. You can also set these URLs and environment as environment variables in the operating system. So that makes it really like Docker friendly. So you can put it in a container and just deploy it. And you can have different containers running the same exact executable with just different environments for that. So we've actually started. You can see we're listening on this port. So let's jump over to my machine and just go home. And the first time it runs, it takes a little bit of time to start up. It takes, it's got to do that just-in-time compilation, get everything ready to run. So it takes a lot longer than all the subsequent requests. And you'll notice that right now. See, it took a little while took almost 17 seconds to start up here. But when we go back, it's pretty fast. Look at that. Homepage, 11 milliseconds. It's faster than my Core i5 over here. How is that possible? Click on the About page. Click it again, 58 milliseconds, 13 milliseconds. All right. I'm even logged in already over here. Let's go ahead and log in.
Pentium chip, huh?
Yeah,
Pentium
it's
computer
really
equivalent.
So, here we go. I'm over here. Everybody watch the light, right? Keep your eye on the light. I'm going to click the toggle button. Turned off. Turned on.
Yeah,
turned off.
That's it.
13 milliseconds. Turned on. Turned off. Right? And that code is very similar to the code we looked at before. It's basically on post toggle. So, we can go into the pages, the About page, and I've just got the little submit handler here, does a post back. And then it calls this on post toggle. We open up the controller, open up the pin. We make sure it's open. We're making sure it's not already open. And then we just set the mode. We toggle it. We read the mode. We say, is it already on? If it is, turn it off. Is it off? Then turn it on. Not too bad.
So in summary, this is pretty good. So in summary, tell us exactly the point of the presentation.
Well, right here on this website, you can actually write a really nice website in .NET Core that allows you to control devices in the real world that then, you could give that web interface to people to, work with, right? So if you put this out on a factory floor and somebody's got to, do something with these and it maybe has to be somebody who's, not a computer expert. They just want a web interface, right? So they can come in here and they can say, turn the device on.
Yeah.
Right? And I'm clicking this with my hand. I have a touch screen. Turn the device off. Right? And you can write all that in .NET.
So you're saying I could toggle that from my browser over here?
Yeah, actually, this might, we might have done something there, Russ, where this is on the public internet. Can you go to that URL I gave you earlier?
Sure. I'll do a countdown, and I'm going to press the toggle button. So everybody watch that light down there. Ready? 3, 2, 1.
Look at that. So,
oh, baby.
From Russ's house, he just turned a light on in my house. I'm in Sarasota.
I'm in Newport Richie.
Like, that's crazy. Do a countdown again. Let's turn the light off.
Sure.
Everybody watch that. Look, my hands, no hands.
Well, 3, 2, 1, off.
He just turned the light off over the internet.
I love it. I love it. I love it. That's great, Tim. That is great.
Yeah, and I'm not a UI person, and I know Russ, you actually, your brother is the UI person there because, we're developers, right? So this isn't the greatest UI here. We've got a simple toggle button and everything else. But, we get a UI designer in here and make this look really nice. You could actually have it like when you think about this camera here, you could have a web interface that says, turn the camera, right?
Yeah.
Because it's got these motors connected to it and you could turn the camera.
This is how a lot of these new security doorbells are built, right? It's got an IoT device in them with a camera on it and a motion sensor And as soon as that motion is activated, then the camera will come on and start streaming the video. So I think the applications are endless, and IoT definitely is one of the big areas coming up, in my opinion.
Yeah, I mean, one of the things we could do too is we could write an API for this, right? So that we could, when we break the build, the light could turn on.
That's right.
Right, or big red light. You could have a big red light. You can this is low voltage stuff, but you can get a relay. I'm not an electrical engineer, an electrician. I'm a software developer. You could get a relay though, which allows you to connect to higher voltage, you know, your house mains, your 120 volts, 40 amps, that you can turn on. The relay uses a low voltage signal to turn it on, and then you could turn a big light on. You could turn a ceiling fan on. You could say the temperatures hit this, automatically turn my ceiling fan on. So what else can you do? Like, can you use all the .NET standard libraries in this? You can. You can actually log into SQL Server. Like, my login here is using the standard ASP.NET Core identity libraries, which are .NET standard libraries, right?
Yeah.
And they're talking to SQL Server. In my .NET here, you can see I have a connection string that's connected right here.
It's out to, yeah.
To an Azure database.
Yep.
And I'm going to show you that. I'm going to log in.
Yeah. This is where you're going to show the code, right? The SQL statements.
Yep.
We like to build things to a crescendo on our webcast, and this is it. So get ready.
All right. So now I'm logged in, and we can come over here, and we can actually look at the SQL that ran when I logged in.
Oh, look at
because
that.
I've got Mini Profiler from the folks at Stack Overflow on here, and you can see the SQL that ran, how long it took to run. It took, what, 4 milliseconds for that?
Yeah.
And then 400 milliseconds for that SQL, 152. And you can kind of look in there and see I'm connected from this Raspberry Pi to an Azure SQL Server. I can log data that way. I could also connect to an IoT hub in Azure and log data that way. There's lots of things you could do here. I can also use the standard. Who's used App Insights for their application?
Yeah.
Right. You can use App Insights on here. It's a standard ASP.NET application, right? You can use App Insights. You can use any of your .NET standard libraries.
Wonderful.
Yes, yeah, so I got one more thing, Russ. I was up late last night. I wanted to, this is the mobile dev group that you've partnered with, Fustino Brothers and the mobile dev group, right? So what does this have to do with mobile developers?
Well, let's find out.
All right. So when we write a mobile application, right? I prefer Xamarin because I'm a C# developer. I like writing in C#. We usually talk to our servers through a REST API, right? So we have something in our app like this, maybe something like a Blink controller, and we just have an HTTP post. We inherit from controller base. We say it's an API controller. And we just come in here and we turn on a pin through an API. What do you think?
Wow.
All right, wait, it gets better, Russ. I took the Xamarin template that comes in out of Xamarin, just the default template, right? And I said, what can I do with that? Can I connect to that easily? Can I jump in? I added the API. I added a button on the about screen just to the standard default template. And I just make sure we're connected here. And then I post to my API. You can see there's my Raspberry Pi URL, right? And I post to API Blink. We come over here to here, and we can see that I'm sitting on API Blink post, right? And I just say toggle on or off.
Oh, beautiful.
Right? On or off. Basically, I come in here and say on, and then I just say on or off.
And there's the post async right there. Yeah.
Yeah. So keep your eye on that light.
All right.
Let me log on to my device and keep my password hidden here. And so here's the app. See, no strings, no wires, right? So I want you to watch the light and watch me hit the toggle button. Look at that.
Wow. Yeah.
Mobile app talking to the real world, all in .NET, all written in C# .NET.
And the crowd goes wild.
Amazing.
If we had a little more time, I would have sent you the app, Russ, and you could have done it remotely. But ran into that time block. So that's it for me.
At this point, let's unmute our guests and see if we have any questions from Q&A out there.
And Tim, great job. Great job. This was an incredible webcast. We'd love to have you back again.
Yeah, so I run the Bradenton.net meetup, and I run the Bradenton IoT meetup. So I'm always playing and tinkering and doing with this stuff. So yeah, I'd love to come back. I'm sure I'll have something cool that I'm working on in a couple of months that might be interesting with the mobile apps and IoT. I've actually considered. I'm thinking about this, and I don't know how the reception would be of doing an open source project that is a generic web interface and mobile app called like TinkerPi, right? That allows you to turn on and off anything, right, on the Pi from the from the mobile app and the web API, and just open sourcing it, right? So anybody could use that as a starter project for their project, or they could use it to just tinker around on their Pi.
Yeah, this is great. You gave me enough to get started in this. That's for sure. I think I got a Raspberry Pi kit, as a matter of fact, at a conference like a year ago. So I'm going to dig that out and hook up that board and wires and start looking at this. This is fascinating. Fascinating.